The graph of the cubic polynomial f of x is rotationally symmetric about the point 2018, and f of x equals 0 has a double root at x equals 2. Compute the sum of the coefficients of f of x. Okay, so let's take a moment to parse what this problem is asking us. So the problem gives us that the graph of this cubic polynomial f of x is rotationally symmetric about the point 2018. And what does that mean? It simply means that if you draw the graph of f on the Cartesian plane and you look at this point 2018, then f of x kind of does the same thing on both sides of this point 2018, except you're kind of rotating f of x. So for example, you could have a function that looks something like this. And then it would look something like this. And obviously this is not a cubic function, it's just giving you a sense of what this rotationally symmetric would mean, because if you rotate this function about the point 2018 and you rotate it 180 degrees, or you simply turn your head upside down, you get the same thing. And another example of a function that's rotationally symmetric about the point 2018 is if you have something like this, and it touches the x-axis at some point, and then it just goes down. And once again, this is kind of probably not what f looks like, because f is a cubic polynomial, but if you were to rotate this 180 degrees, you would get roughly the same thing. So that's what it means when f of x is rotationally symmetric about the point 2018. And then we're also given that f of x equals 0 has a double root at x equals 2. What does that mean? Well, it just simply means that f of x has two factors of this x minus 2 thing. So f of x is going to be x minus 2 times x minus 2, or you could write it x minus 2 squared times something. We'll get back to what this something is later. And we want to compute the sum of the coefficients of f of x. And a tip for doing problems that involve finding the sum of coefficients of a function is, well, let's just say you have f of x is equal to like ax cubed plus bx squared plus cx plus d, or something like that. If we want the sum of the coefficients, a useful trick is just plug x equals 1 in. You get f of 1 is equal to a times 1 cubed, which is a, plus b times 1 squared, which is b, plus c times 1 plus d, which is a plus b plus c plus d, which is the sum of the coefficients of f. So if we are able to find out what f of 1 is, we should be done. Okay. And so now that we've taken a moment to actually understand what the problem's asking us, let's get to work. Okay. We're given f of x equals 0 has a double root at x equals 2. And what does that mean? Well, if you've seen graphs of functions, polynomials that have double roots, like for example, x minus 1 squared. If you try to graph that on a Cartesian plane, what you're going to end up with is something that looks like this, where it touches the x-axis at the point where x equals 1, but it never actually crosses the x-axis. And this is true for all double roots. Like if you had something like x plus 3 x plus 3 squared times x minus 1. I'm just throwing something out there. It would look something like this, where it goes down and then kind of crosses back at 1 and then goes all the way up. And you'll notice at this point, -3, the function would touch the x-axis, but it wouldn't cross it. And obviously this drawing is probably not accurate, but you get the sense of what's happening. And for our function, f of x, whatever this f of x may be, at the point x equals 2, so at this point 2, 0, the graph of the function touches but does not cross the x-axis. So it either looks something like this. I should do it better. It either looks something like this, or it looks something like this. Okay, the next thing to note is that f of x is a cubic polynomial, which means that we can express f of x as a constant times x minus 2 squared times x minus b for our third root b, right? Because f has two factors of x minus 2, but it's a cubic, which means there's a power of 3 for the x's. That's the highest power x can take in this expansion. And we also know it passes through the point 2018, but not just that, it is rotationally symmetric. And so what f of x, if you can kind of visualize what the graph looks like, it's going to look something like this. It's going to drop down like this. It's going to be tangent at 2, 0, but it's not going to cross the x-axis. Then it's going to touch 2018. Then it's going to go up a little bit because it went down before. Then it's going to go all the way down to negative infinity. This is kind of what f of x is going to look like. Okay, at this point you might say, well, what good does this do us? But really, turns out we can actually find some more information about f of x. Namely, what happens if you rotate the point 2, 0 about the point 2018, right? 2, 0 is on the graph of f of x, and we know that f of x is rotationally symmetric about 2018. So what happens if we rotate the point 2, 0 180 degrees around 2018? Well, you'd end up with this point, and rotating 180 degrees is just equivalent to making a straight line between these 3 points. These 3 points would actually be collinear. Not just that, this 2018 is equidistant from both points, which means it's the midpoint. And so what we have here is this point over here, in order for 2018 to be the midpoint, 38, 36. Okay. Now at this point, I'm going to stop and say that we have enough information to solve for what f of x really is. And what we can do is we can plug in x equals 20 and x equals 38 into this formula, and we can solve for a and b, right? So we have f of 20, which we know is equal to 18, is equal to a times 20 minus 2 squared times 20 minus b. We also know f of 38, which is equal to 36, is equal to a times 38 minus 2 squared times 38 minus b. Okay? And we can actually just divide these two equations by each other. And we get 36 over 18. Actually, I'll just write it out. 36 over 18 is equal to a times 38 minus 2, which is 36 squared, times 38 minus b. And on the denominator, we have a times 18 squared, 18 is 20 minus 2, times 20 minus b. And miraculously, this a cancels out with this a. 36 and 18 cancel out to make 2. And we can do some simplification on these two. Cancel out a factor of 18 squared. We get 2 is equal to 4 times 38 minus b over 20 minus b. And therefore, we get 2 times 20 minus b, which is cross multiplying. It's equal to 4 times 38 minus b. 38 minus b. And if we expand that out, we get 40 minus 2b is equal to 152 minus 4b, meaning 2b is 112 and b equals 56. Okay. That said, I'm going to clear up some space so we can try to figure out what a is. Okay. And so let's take a look at this equation. 18 is equal to a times 20 minus 2 squared times 20 minus b. And we're going to plug in b equals 56. We have 18 is equal to a times 20 minus 2, 18 squared times, well, 20 minus b, 20 minus 56 is equal to negative 36. And if you divide both sides by this quantity over here, you're going to get a is equal to negative 1 over 18 times 36, which is equal to negative 1 over, if you multiply the denominator out, you get 648. Finally, remember what we said about finding the sum of the coefficients of f of x. We want x equals 1. So f of x is equal to a, which is negative 1 over 648 times x minus 2 squared times x minus 56. So the sum of the coefficients when x equals 1, you just plug 1 in, you get negative 1 over 648 times 1 minus 2 squared times 1 minus 55. For a final answer of negative 1 over 648 times negative 1 squared is 1, and this negative 55 over here, and you get 55 over 648. And we are done. So thanks for watching, and I will see you next time.